right, good morning or good afternoon. Happy Monday morning. I hope you all had a great weekend. We're going to start again, lesson 67. We're going to keep trudging along. Today we're going to talk about transformations. This is just an introduction to a few transformations that you probably have already heard of. So this may not be a lot that's new, but we're going to define several things today. The first thing we're going to define is, what is a transformation? What is a transformation? It is a change in position, size, or shape of a figure. Okay, a transformation. We have changed the position. We've moved it somewhere. We could change its size. We could change its shape. That is a transformation. Okay? There are 3 types of transformations that actually don't change the size or shape. Okay? I'm going to go ahead and define this one. It's an isometry or an isometric transformation. Okay? Isometry is a transformation that does not change the size or shape of the figure. Okay, so let's have some examples. So for example, a reflection is a transformation that doesn't change size or shape. A rotation and the last one, you know it, it's just a translation. Yeah. So they are all isometric shapes.
What's up?
Not much. How are you?
Sorry. Are you talking to them?
I am. If you want to say hi, these are my geometry kids.
Where are they? Where do I look?
They can't see your face. They can just hear your voice.
Hey guys, it's Mama Morgan. I'm super glad you can't see my face right now because I've been scrubbing patio furniture. Love you. I had a boy call and he forgot to get his national park paper.
Fun.
Yes.
Bye. Okay, love interruptions, just like we're in real class. Okay, so reflections, rotations, and translations are our isometric transformations. Okay? All right, so let's look at a few things. First, we're going to be moving some shapes around a lot. So I'm going to scroll down just a little bit. Okay? So let's start with a simple triangle. If it will come up here. We're going to take a simple triangle and we're going to name it. What are we going to name it? It doesn't matter. A, B, C. Okay? And we're going to take this triangle. Okay, let's see if I can duplicate. Here we go. We're going to duplicate. And we're going to move it. Ooh. Don't take both of them. You're supposed to take one. There we go. We're going to take one and we're going to turn it a little. Okay? So that A, B, and C. So this A would correspond to this A, and they would be congruent. This B would correspond to this B, and they would be congruent. Same thing with C. Same thing with, what about the side lengths? Are they the same? Of course they're the same. They have to have the same area and the same perimeter. Okay, but we can't have two triangles have the same name after we've moved Okay? So our second triangle, the one we have changed, we put these things called primes. Okay, these little dash marks. So that is called A prime. Okay, and B prime and C prime. Okay, so A prime is simply A with a little dash on it. Okay, now the image A prime, B prime, C prime is called the image because it's after we've done a transformation on it. The triangle ABC we call the pre-image. Okay, it's before. It's the original shape. It's before we've done any transformations to it. Okay. Isometries are called congruency transformations or rigid transformations. Okay. These are also called, let me do this little, also called congruency or rigid. I don't like that I've written all this in here. That's not a D, it's a G. Rigid transformation. So if somebody is talking about a congruency transformation or a rigid transformation, they've either done a reflection, a rotation, or a translation. Okay? So let's look at some shapes and talk about each one individually. Okay, I'm going to start with the last one. A translation is simply a slide. Okay? I want you to use the geometry word translation, but just know that it's just a slide. So we're going to take an image. It does not matter what image. We can even do a star. Okay? Then we're going to take that star. Of course, I'm going to duplicate it. And I'm going to move it. I've just created a slide. Did you see that? I just slid it over. Okay? So if we were to name it, we would have A, B, C, D, E. We would have A prime, B prime, C prime, D prime, and E prime. Okay? That is a slide. It's a type of transformation that shifts or slides every point of a figure the same distance in the same direction. Okay? Well, maybe we need to write that one down. Shifts. Maybe I'll put this in parentheses. It's a slide. It shifts or slides. So I'm going to put shifts every point of a figure the same distance in the same direction. Okay, that is a translation. That's one type of a transformation. Those two sound a lot alike, but they're not. Next, we have a reflection. A reflection is also called a flip. Okay? A reflection is called a flip. Okay? A reflection is a transformation across a line. Okay, it's across a line that we are going to call the line of reflection. Such that the line is the perpendicular bisector okay, perpendicular, I'm going to write like this. The perpendicular bisector of each segment joining each point and its image. Okay. All right. Well, that's a lot of words to say something kind of simple. Okay. So if we want to reflect a shape, we were generally going to have to tell it what shape we want to reflect it across. Okay, let's do an arrow this time. Okay, so if I have, let's go ahead. Well, I'm going to do something a little different. I'm going to scoot it over this way, and then I'm going to draw a line. I'm going to take this line, and I'm going to say I want it to reflect across this line. Okay, so I'm going to take my arrow. Do we need to name it? Probably. A, B, C, D, and E. Someday I'll get more creative. If I want to reflect this arrow across the line L, okay, I probably need to duplicate it. Means if I fold my paper on this line, now the first question is that reflected? Absolutely not, okay? Does that look more reflected? Yes, that looks a lot better. Now, does it have to still be the same distance from the line? Yes, it does. Meaning, okay, let's see. This distance and this distance must be the same. Okay? Really, point A must be the exact same distance and lie perpendicularly to this other point. Really, because that would be A prime. The image and the pre-image must be perpendicular to each other across that line. Okay? Now, B is a lot farther away from line L. Okay? So, B prime must be that far distance away also. What about C? C is pretty far away, so I would jump all the way over here to do C prime. Same thing goes with D and E. And E prime. Okay? Meaning if I fold my paper on line L, the two arrows will be directly on top of each other. It flipped over. I can envision right now, I know you can't see me, but try to envision this, picking the arrow up and placing it on top of the other arrow. You're folding that paper. Now, sometimes I want to reflect about a line that's already there. So let's look at a different shape. What's a good shape to do? Maybe I'll do this one. That's a neat shape. Okay? You can take any shape. This works with any shape whatsoever. This time I'm going to do A, B, B a little different, B, C. And I want to reflect across segment AB. Okay, how would I do that? So pretend I'm not going to do my shapes anymore. I'm just going to draw like you would on your paper. Okay, so AB is going to stay there. I'm going to reflect across this line. So guess what? A prime and B prime will be in the exact same spots as A and B. Okay, and then I'm just taking my shape and I'm flipping it over. Oh, we're going to pretend that this is here. Okay, so this is the curve and my C prime is up here. That's very messy. I'm going to take a little bit of that away. Might as well take most of that away, right? Because it's a little, so here's B and here's B prime. And then it comes down at a right angle. So C and C prime, such that the line that is perpendicular bisector of each segment joins the point and its image. So here to here, the line joins and bisects it. They have to be the same. And they're perpendicular to each other. Okay? Reflection. Just remember it's flipped over. And it doesn't have to be, it can be touching or it can be farther away like the first one was. Okay? All right, last but not least, in our isometric transformation is called a rotation. A rotation is also known as a turn. I always think about turning the knob like a door handle or something. Okay, it's a turn. All right, it's a transformation about a point. So this time we're going to be talking, you're going to translate or rotate about a point. We call that the point or center of rotation. The point or center of rotation. Okay, such that each point and its image are the same distance from that point. And the angles formed by the point formed by a point, its image, and the point of rotation are congruent. Whew, that one was a long one. Sorry about that. Okay, rotation, I will say, generally tends, when we get really in depth, tends to be the hardest one, believe it or not. It's kind of crazy. But we're going to stay fairly simple today to talk about a rotation. What's a good one that is going to rotate nice? I do. Maybe I'll just make my own up. One that looks something like what's in the book. Okay. So I've got this random image that I'm going to go ahead and duplicate because I'm not going to try to draw it again. Duplicate. And I'm going to transform. I've got these. I don't remember what they actually do. Okay, watch this. I can handle that. I'll change something. Okay, so we'll use that in just a second. First things first, I need to name it, because you need to name all your images. Let's go QRST, and I'm going to put U here as the little piece in the middle, okay? So most of the time, they are going to have a point of rotation that is one of the points. So maybe I want to rotate about point T. Okay? Most of the time they're going to tell you how many degrees. Not in this lesson. We don't get in depth. It's later that we will get in depth about like turning 90 degrees, where we're based. I don't think I should have flipped that. Here we go. We're going to flip it back. Oh no, just give me my piece. My form. Okay, yes, that looks much better. Okay, so if I had taken this and gone like this and moved it back over here, moved it back over here, rotated it some more, it would be right on top of this one, right? So at the top it's RQUTS. Okay, so I'm going to turn and I'm going to move about point T. Probably want to turn it a little more. But I didn't specify how much I wanted to turn it. Okay? So, when they're talking about the angles, whatever angle that I've made, They're simply saying that the point S and point S prime from the image S prime to the point of rotation back to the point S, okay, will land in a specific angle, okay? And then R to the point T to the point R prime will be in that same angle, okay? So if, we're going to pretend, this is going to get a little messy, STT to U, if we measure that angle, it will be the same as R to T to R prime, okay? That angle will be the same. That's what they're talking about with the angles, okay? Q, if we did the same thing with Q, to T to Q prime. Oh, that was a bad. Q prime. They would all have the same congruent angles. Okay, I'm going to erase some of my extra lines now because they get a little bit hasty. I'm probably going to erase the U. Okay, that would be a U. Here we go, U prime. What about T prime? And we would name these. We would have the shape QRSTU. QRSTU is congruent to Q prime, R prime, S prime, T prime, U prime. We would have to keep all those primes in there if we wanted to continue to talk about that, okay? That would distinguish which shape we were talking about, okay? Then it's just performing transformations, and can you identify which one is which, okay? Not anything too crazy. We do see a lot of transformations in life. I mean, if you're doing people that model or remodel, oh my goodness, I just thought landscaping. I don't know why. Generally, they put some form of symmetry in. Anything that's got that symmetry where we can see the same thing on one side as we see on the other. There's a stained glass window design they talk about. Sometimes in houses, they're like that. They want the same in each place. Apartments, they generally have one layout and they pick it up and they put it in another place. That's a type of transformation, okay? So we had translations, rotations, and reflections. Those are your three that we will talk about. I am going to go ahead and assign some homework from this lesson. This is just an introduction. We'll get more in depth with all three of those later. Okay, so lesson 67, we're going to do the practice, the A through D, and numbers 1, 3, 6, and 14. All right. I think I said last week we would have a test. I'm probably going to go ahead and plan for that test on Thursday. I'm going to go ahead and try to put it in RenWeb. Test on Thursday that will cover lessons 1 through 65. Okay, so it's just the lessons we've already done, not even the one we did Friday or this one. Okay, I'll post that on RenWeb, and I'll put it in our Google Classroom also. So probably have done that by the time you're watching this, I hope. So have a great rest of your Monday. Bye.